All right, this is going to be the next video in the principle of mathematical induction series. We're going to be looking at this first example. So, first example, they want us to prove by induction that the sum of the first n odd integers is equal to n squared. So, in algebra terms, that would be 1 plus 3 plus 5 plus 7 up until 2n minus 1 equals n squared for all integers where n is bigger to or equal than 1. The first step that we talked about before was to demonstrate that this is true when n equals 1. So I'm literally going to substitute n equals 1 into the equation. So here, the general form on the left is 2 times n minus 1, so 2 times 1 minus 1. On the right, we have an n squared, so it's going to be 1 squared. Now I'm going to do the algebra one step at a time to show that both sides simplify to be the same thing. 2 times 1 is 2. That 2 minus the 1 that I already had is 1. On the right-hand side, 1 squared is 1, which does end up being the same as the left-hand side. Check. The second step that we talked about was assuming that the expression is true for when n equals k. So I'm going to write a statement that says literally assume that 1 plus 3 plus 5, etc. is true for all integers. The only thing I've changed is that the former n is now a k everywhere in the step. Step 3 was to do the algebra to show that this is true when n equals k plus 1. So I'm going to use the first strategy here, adding the left-hand side's version of 1 more to both sides and show that the right-hand side's pattern continues. So on the left, I had 1 plus 3 plus 5 up until 2k minus 1. So I'm replacing this k with a k plus 1 to add another term of the left-hand side's pattern onto the left. In order to keep this balanced and equal, I have to add this same term, the same expression on the right. So this light blue I've added to the same on both sides. Then on the left side, this means my original pattern just goes up to k plus 1 instead of stopping at k. On the right-hand side, I need to combine and simplify this. So 2 distributed into the k plus 1, 2 times k is 2k. 2 times 1 minus 1 ends up being 2 minus 1, which is 1. Now you should notice this right-hand side is a pattern we've seen before when we talked about quadratics. This is a perfect square. This can factor into k plus 1 in parentheses squared. Now notice what I have here is an expression that's the same as the one I started with, but all these places I had k before are now k plus 1s. So I can replace the k plus 1s with my n. So this means that n equals k and n equals k plus 1 at the same time. So my fourth step is where I can conclude by the principle of mathematical induction. The statement that I wanted to be true is true. The sum of all the first n odd integers is equal to n squared. Okay, you do have to rewrite the statement. Don't just say by the principle of mathematical induction, it is true. It's not enough. All right. If you feel good with this, then try example 2 below, and I will post that video next.